Welcome. This video will accompany the 9.1.2 notes, which hopefully you have printed out already and you are ready to go. So I'm going to do some highlighting as well, just like normal, and go through and work out these three problems with you. The majority of today's assignment is going to be reviewing some stuff that you did in 9.1.1 and doing some word problems, so not a huge amount. So if we take a look at these questions, what we want to do is basically do what we did before whenever we had word problems trying to write an equation. So the first thing I'm going to do is I'm going to try to write it into an equation. So I'm going to translate the words into an equation. Then I'll determine if an inequality makes the most sense. So I look for totals, I look for different variables or things that are going to be changing. So super straightforward, really going to treat it just like an equation. So if you take a look at the first one, we have a gift certificate that's worth $20. Okay, that sounds like a total to me, so I think I am going to come back to that in just a minute. Then let's take a look at the rest of it. Charge is $1.10 for the first minute. Normally when they're saying it's like for the first minute or for the first five or like you start with, this is almost like your initial value. So I'm going to say this is my initial value here. So I would say this is my initial value. But then I've got this thing that's kind of changing over time. So for each additional minute. All right, so if I went through and I was on the phone for 1 minute total, then I have to pay the 110, period. But then as soon as the next minute kicks in, I have to pay the $1.10 and now 42 more cents. So this is the growth factor that we're thinking of. So how much this is growing. So this is my growth. Looks to me like it's the equation of a line. So I think what I'm going to do is I'm going to write out what I know. And then I'll identify some variables in just a minute. So I would say that I am starting with $1.10. So that's going to be my y-intercept, or my beginning value. And then I am going to increase by 42 cents for every additional minute. Okay, so I'm going to identify my variable here. I'm going to let x represent the number of additional minutes. And then if I put this equal to y, I think this represents the amount of money that I'm going to spend. Now, again, I'm just writing an equation. That doesn't mean I'm going to keep it this way. So I'm going to let y be the amount of money spent, or amount of money total. Okay, so now I'm going to go back up to the question. And I had that 20. So if I take the $1.10 plus the 42 cents for every single minute, now I have a limitation on how long I can speak. I can only speak up to $20 worth. I can't speak more than that. So I think what I want to do here is I want to move my y to the other side. It looks like I got rid of the y at the end of the money, so let's put that back. So I think I want to do y over here. Not that it matters, you can put it on the left or the right. But basically, if the 0.42x plus 110 represents the total amount of time and money, so then I would expect this to be 20 on the other side where the y is, because that's the amount of money that I'm allowed to spend. So we can spend the exact $20. So I'm building my inequality here. So it could be equal, or, well, I can't go over more than what I have. So I can either be exactly at 20 bucks or I can be lower than the $20. So the left-hand side is going to represent, so this here represents how many minutes, because the X is in there, how many total minutes I am allowed to talk on the phone using this gift card until I run out of money. So the $20 is when I run out of money. Okay, so I have my inequality. Now, I like to treat it like an equation. So now I'm back to what we did on 9.1.1. So I'm going to take this guy and I'm going to solve for x. So I'm going to minus my 110. It's going to give me 18.9. Then I would divide. Those are going to cancel. So it looks like x is going to be equal to 45. Okay, so if I plug 45 in to the equation, so back where I started here or here, then I am going to get that when I have talked on the phone for 45 additional minutes, then my phone's going to cut out. So as soon as I finish my 45 additional minutes, at the very end of it, the phone will be like, okay, that's it, you can't talk anymore. So what I have here is that I can talk up to, so I can't go over it. I could go less if I wanted to kind of save money on the card, but if I didn't want to and I wanted to use every last penny of it, then I can say I can talk up to 45. And again, this was additional minutes. So if you wanted to think about it, that would be a total of 46 minutes, because the $1.10 covered the first minute that you were on the phone. Okay, that covers our first one. Now, the second one is just like it, really just like it. So now would be a great time for you to pause the video and see if you can set up the equation the same way, instead of pausing and then working through it so you guys will automatically see the answer. I'm going to go ahead and work through it, but I do want you to, if you're ready, just pause the video and then unpause it and kind of follow along and see if you did it right. Okay, so I have my flat rate of $1.75. So I know I have to pay that $1.75 for sure. Then I have additional 65 cents per mile. So I would say that that is 0.65x, so per mile. And then if I set this equal to y, that would give me the total amount of money, or the traveling part of this. So I would say that x represents additional miles, so number of additional miles. So again, just like the previous question, and then y would be total amount of money. All right, now let's see. Oh, it tells us how much money Erica has. So Erica has at most $10, so she can't go over that. So again, set up just like the last one. So I would do 0.65x plus 1.75. The total amount of money is 10. So she could spend all of it, so equal, but she can't go over it. So she has to be less than or equal to the 10. Okay, so now let's go ahead and solve it as if it were an equation, or you can leave it as an inequality and solve it that way if you would like. That's totally fine. I know this is something that you guys have probably already been exposed to, so if you want to use prior knowledge, I'm all for it. I think that's a great idea. Okay, so now if we do that subtraction, that gives us 8.25, and then we're going to divide by 0.65. Those are going to simplify. It looks like x is going to be equal to, it doesn't come out exactly. I think it comes out as an approximation. So approximately 12.692, and then there's a whole bunch of numbers after that. Actually, let me double check it and make sure that I typed it in correctly. Yep. Okay, so let's see. I would say, the best we can do here is an approximation. So I would say she could travel approximately, let's see, 12.6. We don't want to go over for sure because she would have already run out of money at that point. She could travel approximately 12.6 additional miles. Where we know for sure she has to pay the flat, actually, yeah, she's got to pay the flat rate. It doesn't say that that is for the first ride, first mile or not. So she's got to pay the $1.75. So I don't even know necessarily that this is additional miles. I think she only gets to go 12.6 miles, period. And then I go back up here. Let's get rid of these additional miles as well. So it's worded a tiny bit differently than the previous question. Okay. All right, so approximately 12.6 miles. Moving on to the third one. Now, this question can be solved a couple of different ways. It's ultimately up to you. You guys could have actually solved the two previous questions as just equations, but then if you were asked to, write an equation or an inequality that models the behavior of what's happening in the problem, we would definitely need an inequality. Okay, so let's see what we got here. So Bill spent less than $26. Okay, less than. I hear an inequality right there. On a magazine. All right, so a magazine and 5 composition books. Okay, so I'm already hearing that I need M for magazine and C for composition books. So 1 magazine plus 5 composition books. I think I'm going to go straight to the punch on the inequality here. The total is 26, but it said that he spent less than that. So all of the money from the magazine and all of the money from the 5 composition books totaled up to less than $26. So if somebody asked me, hey, can you write an equation that models the behavior of what's happening in the problem? I said, yeah, absolutely, it's right there. So that's my inequality, but I do need to identify my variables. So I'm going to let M equal the number of magazines. Or excuse me, that is not true. This is the cost per magazine. So cost per magazine. We already know that he already bought 1. So this is cost per magazine. And then we're going to let B equal the cost per composition book. I'm jumping all over the place with my variables here. So let's do C, just like I did with my equation. My goodness. So cost per composition book. Okay. All right, let's keep reading. Hopefully, because I don't think I have a second equation in here. Let's see if they give me some more information. The magazine cost $4. Oh, okay. All right. Well, I already know what that is. Then let's plug in the 4. So I'm going to plug in a 4 right there. And then I know 4 times 1 is just 4. All right. I'm not going to do anything more with this inequality until I know what they want me to do. It's the maximum cost of each composition book. Okay, so I'm trying to figure out what the composition books are. Maximum cost of each composition book. All right, so we're trying to solve for C. That's really what we're looking for. All right, I think knowing that you guys have prior knowledge of being able to solve these, and kind of in the 9.1.1 video I talked about, the only time I got to be really careful is if I'm multiplying or dividing by both sides of the inequality by a negative number. So I'm just going to go ahead and solve this the way that it is now. I'm just going to be super careful about the multiplication division portion of this. So I'm going to move my 4 to the other side. So it's going to give me 5c is less than, all right, I'm going to subtract, that's going to give me 22. Let's see, I'm going to divide by 5. Okay, here's when I'm really paying attention. I have to ask myself, this division that I'm doing right now, is it a negative number that I'm dividing by? And in this case, the answer is no. Since it is not a negative number, I don't have to worry about that inequality sign flipping around on me. So I can keep it. I'm just going to drop it straight down. So it didn't flip because I'm not dividing by a negative. Let's bring the C down. And then, I mean, I've bought composition books in the past, and I know that I don't pay 22/5 for them. So I would go ahead and divide and get my decimal out of this. So 4.4. All right, so since I didn't set up an equation for this, I just went straight to the punch on the inequality, I should now be able to answer the question for this. So it's basically saying down here in my statement that the cost of each composition book, C, is less than, smaller than 4.4. So the maximum that I could spend on a composition book, I have to be lower than 4.4. So let's think about money here. So I know 4.4, that's equivalent to $4.40 if I'm thinking about money. But I want to be less than that because he spent less than $26. So if he spent less than $26, I need to go just less than this. Well, let's think money. The numeric or money value that is just lower than 440 is going to be 439. So immediately below it. So I would say then that, let's see, the maximum cost per composition book would be $4.39. So we can't hit the 26. We're not allowed to. It says that he spent less. All right, and that should cover the notes for the 9.1.2 lesson.